Hello, I'm Peter, and in this presentation, I'll be covering our paper marking material interactions with computer vision. This work was done in collaboration with Sandra Bay, Ruhan Young, and Ellen Du from the University of Colorado Boulder, as well as Clement Jung from the National University of Singapore. As researchers in the field of tangible user interfaces, we are tasked with both designing interactive systems as well as mentoring other designers. Building these interfaces requires physical computing, which is largely driven by off-the-shelf electronics. Designers benefit in their efforts from the widespread accessibility of MCU platforms, such as the Arduino and Raspberry Pi. Despite this widespread use, though, researchers have noted several challenges with the electronics-based physical computing. Notably, creating physical circuits can be an intimidating task for anyone who hasn't encountered electronic components before. Also, debugging circuits can be quite tricky since the flow of current cannot be perceived without additional tools. Based on our previous work with computer vision markers, we realized that they could function as an alternative to electronics in this case. With just a single camera, multiple interactions can be detected without the need for any circuitry. In our pictorial on the printed paper markers project, we explored a range of interfaces, all mediated by CV markers and paper structures. But that was just the work of a relatively small design team. We have continued to develop this CV marker-driven approach and shared it with other designers. In this paper, we reflect on our work with CV markers as a material for physical computing, as well as the results from a series of studios in which we shared this technique with other design students. To that end, we developed Beholder, a web-based programming library that leverages CV markers as a material for detecting tangible interaction. We used an annotated portfolio to reflect on the work from these studios and the approach we took. In this presentation, we will introduce the portfolio and the studios which produced the projects. Then we will discuss the key insights that emerged from reflecting on this collection of work. And through these insights, point towards the strengths and constraints of using computer vision for physical computing. The portfolio that we assembled includes 15 projects that were produced from 2020 to 2022, and this work was done across 3 design studios conducted at the National University of Singapore and at the Atlas Institute at CU Boulder. Studio 1, titled DIY CV Interfaces, was an 11-week design studio class with industrial design students conducted at NUS. Studio 2, TinyCade, was an internal research group project conducted at CU Boulder. And Studio 3, CV Games, was another 13-week design studio class.
Could you stop for a second? Is he getting too fast for anything? For me, it's too fast.
Okay.
Slow down, calm, give us time to process what you're saying. I know you're nervous and that causes you to.
No, that's not the problem. The problem is I have 50 slides. Yeah, we only have 10 minutes at time.
All right, carry on.
I'll try and slow it down, but
Yeah, I mean, I would cut content if you've got too many slides, because we're not getting the point. I think me.
I can cut slides.
Carry on.
But I'll slow down then for you guys. To support the easy use of computer vision in these studios, we created Beholder, and this library wraps a JavaScript implementation of the ARUCO fiducial marker detection algorithm. These markers are easily printed on paper, which designers can then stick onto their constructions to track interactions. You can see here what a debug feed might look like when trying out these markers. Once detected, a marker offers a range of values that can be used to sense interaction, including presence, position, rotation, and a unique ID for each marker. In Studio 1, students were challenged to develop DIY computer interfaces for everyday activities, anchored on the themes of work, learn, and play. This brief was provoked by the fragility of the global supply network highlighted by the COVID-19 pandemic, which increased interest in DIY activities. We saw a diverse set of topics from the 7 projects produced in the studio. For example, one group created ARU controls, a tool for mapping marker interactions to keyboard output on a computer, and another group created Hexbox, a cardboard game controller kit with swappable bespoke inputs. With Studio 2, we wanted to focus more on play as a context for tangible interaction. We also set out to explore smartphones as an all-in-one. With these specific goals in mind, we organized this studio to run within our research group with designers who are already familiar with Beholder. They created TinyCade, a DIY platform inspired by arcade machines that exclusively features the use of commonplace materials like cardboard and toothpicks. And for this platform, 3 games and 1 educational kit were developed, each with their own bespoke interfaces. The TinyCade platform itself features 2 mirrors on the inside, which enable the phone to function as both a detection device and a display. Our final studio, CV Games, was inspired by TinyCade, as well as the many big game-based projects from Studio One. In this studio, designers were challenged to develop new DIY video game platforms for a specific audience. In total, 6 games were produced, though for 2 of these projects, the designers opted to use a different technique than CV markers. Some of the games produced here include Cade Cafe, a game platform that facilitates full body interactions through markers that can be attached to a Velcro suit, or ARU Scan, a toy which enables caregivers to map CV markers to specific images and sounds for kids to find and scan. We collected all the work from these studios into our portfolio for reflection, and through our reflections, we examined a couple of key themes. How did designers use CV markers to detect physical interactions? And what physical mechanisms did they construct to facilitate their use of markers? How does practice of physical computing with CV markers compare to that of electronics? How did designers understand the mechanics of building physical interfaces with CV markers? What interface materiality did CV markers facilitate? Oh, that was the last one. Our first insight centers around how CV markers mark identity and interaction constraints. With electronics, designers will often use a different component to sense a different interaction. For example, a button for presses and a potentiometer for turning. However, with CV markers, a single component is capable of sensing a wide range of interaction due to all of their values. The simplest value a marker provides, presence, was used in a variety of ways throughout these studios. Presence can be disrupted momentarily to detect passing instructions, such as a coin counting mechanism in Fun Fun, or used to indicate a certain state, as with the D-pad in the Light Cycles game for TinyCade. We have collected and categorized all of the techniques designers used across these projects into a set of examples, and you can see which projects use each of these by looking at our portfolio site if you're curious. Important to most of these examples is how designers can identify distinct but similar interactions simply through using a marker with a different ID in the same way. Our second reflection was on how CV markers mark interaction events in the physical world. For example, a marker can continuously report on the position of a slider by checking the marker's position in the detection feed. They can also be used to mark an event in the physical space, placing markers along a track, which get revealed through interaction. We view this use of markers as a kind of programming in the physical world. Instead of a series of if statements in code, you can place a marker where you want the event to occur and then respond to the marker's presence. We also observed a method of debugging CV markers with human vision. When working with electronics, there isn't really a sense that humans have that can detect the flow of electricity unless the voltage is too high. But with CV markers, people can easily identify if markers should be visible to the camera and can then determine if the bug is in their interface or in the detection side without checking the computer. This leads us to the materiality of physical computing with CV markers. The markers themselves are usually made out of paper, but any high contrast rendering will do. They're tied to immaterials like light, camera space, and environmental conditions. And by redirecting light and shadow, you can influence the detection of markers in many ways. CV markers can, of course, be coupled with a huge range of materials. In our studios, we saw paper, cardboard, wood, and acrylic, but others are certainly possible. And with TinyCade in particular, they made use of cardboard since during COVID-19, the designers had an abundance of shipping boxes lying around. This materiality also points to some of the limitations of CV markers. Lighting must be consistent for the detection to work, and a low resolution camera feed reduces reliability. Camera motion blur also posed a challenge, especially on computationally limited devices like smartphones. And when working with CV markers, we are also constrained to sensing only, so you still need electronics for actuation. To wrap up this presentation, this annotated portfolio, we presented 15 projects that used a CV marker-based approach for physical computing. And through reflecting on these projects, we uncovered the following insights about designing with CV markers. They can be applied to physical materials to sense a wide range of interactions. They can be used to directly mark interaction events, enabling designers to program system logic in the physical world. They can be debugged using human vision, thus enabling designers to draw connections between what they see and what a CV system detects. and they enable designers to leverage a diverse materiality, including democratic physical materials such as cardboard and paper. We will continue to explore the technique described in this paper, and we hope that this work will contribute to the range of alternatives that designers can employ for physical computing, and inspire more research in this area too. Thank you. And if you're curious about the portfolio of the library we developed, they're available at these links. Yeah, I got the
You
timer
have
here.
20
Yeah.
seconds to
Yeah.
spare.
So I checked some slides, but I will slow down.
I mean, also, the thank you should be the last thing you say.
Okay.
Yeah,
Once you say thank you, everybody.
people are
Oh,
blocked
okay.
off, they won't hear anything, yeah.
You know, it's not even necessarily slower. But it's making the pauses
Yeah.
for emphasis.
Mhm. I also snuck in some extra jokes.
James.
I like the fucking jokes.
So yeah, now would be the Q&A time, and then if we want to simulate that, we can, or I can go on to showing you the portfolio.
Let's do some Q and A.
All right.
All right, Q&A, questions?
So you've got this environment
Mhm.
that has more of a directed exploration, learning, creating play kind of thing. Had you investigated any of the benefits from a security side that you have with this system?
No, we haven't.
Well,
What did you have in mind?
I'm thinking of just the air gap. There are a lot of environments where if there's an air gap between the computer and the interaction, there's an opportunity to build better security because you have to have that air gap. You can't just electronically tap into it. I wasn't sure if you messed around with like materials like, oh, well, if I don't see this reflectivity, then I'm not going to do anything because they didn't pay attention. They just copied some code, but it didn't have some extra security checks or something like that. I don't know if you've done any of that kind of stuff.
No, we haven't, but I'm sure somebody has. This library, the ARUCO library, has been around for a while, and it's pretty widely used. It's like bundled in core OpenCV, and it was first developed, I think, for robotics.
Okay.
You didn't really talk much about what skills are need, what skills users need to play with this.
Yeah, so to actually make something, the library we used in these studios, you'll need to be able to do web programming with JavaScript. We've simplified it as much as we can, and it integrates with things like P5 pretty well. But outside of that, you still do need to code to be able to get it working, but any browser can run it well enough.
Other questions?
Have you had an implementation on something like Ubuntu or some low-level Linux version?
So we're working on a new version that runs natively instead of in the browser. That's for a different thing, which is what I'm going to show you guys next. And that uses the native C++ OpenCV version. And we're not the algorithm developers.
Right.
We're just using someone's amazing algorithm for other cool stuff.
Do you have ideas for how it could be? I mean, you mentioned that one of the constraints is it's limited to input and sensing.
Mhm.
Do you have any ideas for how it might be used for actuation and outputs instead of just having it on a screen?
Actuation would be pretty hard. I've seen some projects that use, so if you type to a phone, you could do stuff like light piping from the phone screen to do some LED type output if you wanted to not have any electronic components. And then you could try and do stuff with the vibration and sound on the phone, but that wouldn't be a component of the markers. That would be using what the phone already has. That's the direction I'd probably move. Because it's camera taking it in, so it would be really hard to make the markers themselves do output, I think. We've worked with one of Clement's techniques is mecha magnets, so we've combined it with that, so it has better haptics for the interfaces, but beyond what is already embedded in the object, it's pretty hard to get the markers to do outputs, I'd say.
portfolio.
All right, let's do it. So, oh, I gotta switch how I'm sharing the screen. Hold on.
All right. Wait, share screen.
Stop share. Stop mirroring. Thank you guys for going through that. I will talk slower and add in more jokes to the script. All helpful feedback.
Yeah, I would say,
Should Dan told Mike Schneider attend to this, but he didn't.
Let's see.
oh.
That's my
That's
screen.
recorded. Yeah,
That's my
that's great.
text document. Don't put that.
I am,
So yeah, this is the portfolio.
okay,
So these are 15 projects from all the studios. This over here.
so you can show this when people start doing asking questions.
Yeah, that's what I plan on doing,
Yeah.
is I'll pop this up if they have questions about specific projects. The idea with this part over here is that if you have a specific interaction and you want to see what it looks like from our interaction trigger, you can click on it there. And it'll sort by what projects use that. So the thing I'm gonna show you is actually really similar to this. I helped the students that were working on this out with getting some of the keyboard emulation that they were trying to do work at first, but our system is a little bit more robust. This is this project is like one of my favorites because it's that.
Inspired by Hotspot.
Yeah, it's inspired by Hot Swap. The students actually, so we made a game in the past called Hot Swap, which had swappable inputs for the controller, and the students kind of felt bad because they knew about Clement's Hot Swap project and were like, we don't want to steal your idea, but this is the idea we really want to make. But this one's pretty cool. I believe they have a kit out there that you can build on, and they use like rubber bands to get some nice haptics, which is pretty fun. Let's see. I'm gonna show.
The jacket.
Yeah, Kate, that's it.
You wanna see Kate? This
They're
is
very
like,
cute, yeah.
basically a DIY Connect. Right?
Yeah,
Yeah.
This is great, right?
So they weren't actually tracking motions for this project. It was just get the marker on screen to do something, but already that interaction gave them a lot to play around with in the physical space.
my kids have to move, yeah.
And this was from the games studio. And so for all these projects, we gave students basically just, if you're familiar with the website Glitch, which is an online platform where you can like give an HTML template and they can build it out. So we did that setup with Beholder working already in the background. So they just need to figure out how to make their own game.
I don't think the snapping part is the fun.
Yeah.
And then these are like their project videos. So the next
Can
is
be
like
that.
all their inspiration stuff. And you can see, so the two studios, the deliverables for the student is like a vision video at the end. So we have pretty good documentation on what they did for all these.
Would you repeat where the studios were?
The first and third studio were in Singapore with industrial design students at NUS. And Beholder was done here within the Acme Lab research group. Or not Beholder, Tiny Case. Yes.
Maybe, can you say a little bit more about the annotated portfolio method or whatever you would call it?
So the annotated portfolio method is basically taking a body of work that shares some strong similarity. We're lucky because they're all built off the same system, and then using those to reflect on what that is capable of, what that means. Sometimes you can use it to develop a framework. We just really wanted to gain a deeper understanding of how designers use it. And since we conducted these studios before doing the portfolio, we already had the work. So it was pretty easy to take it and reflect on it. And that's how we got to those. We wanted to distill what Beholder was to us down to like a couple of key important things. Oh, and this is the project. So this was the
Yeah.
one that has the slider interaction that is based on like occasional presence. So it's designed for, or was designed with rehabilitation in mind. There's sound here, but I don't feel like making that work.
It's okay.
So it's like this thing with a disc that'll move back and forth. This is the assembly. The idea is it's like this kit that a physical therapist could buy and assemble pretty easily. And then they just need to suspend it. And this was a cool, we had never done this before, so we were really happy when we saw the students do this because it works so much better than moving a marker because there's no motion blur. Since the white disc is bigger than the marker, it'll get detected really consistently, but the graphic isn't moving, so we don't have to worry about like camera latency or anything like that. There's a little monkey feeling.
Yeah.
And there's the
Yeah,
detection feed.
so market doesn't really.
So this is what the, this is what the detection feed overlay looks like when you're working with it in your application. So there's a couple of parameters you can tweak. You can set the camera, you can set what feed resolution you're working with. Which is important because it's running in a browser, bigger feed is slower, but has more pixels to detect markers.
So the white disc just makes the marker visible. to the
Visible, yeah.
camera.
It needs that white border,
Background.
Yeah.
but because we're not moving the graphic, it
Yeah.
makes it more responsive.
Yeah. That wasn't there when you started, but now it is.
Yeah, it's better with the graphic.
You already have a graphic in your presentation, but you just don't explain it. There is this one where you say
I
that
don't explain that that border is important.
Yeah.
Okay.
Yeah,
the
yeah,
marker is
yeah.
always visible, so.
Yeah,
Yeah, without the contrast, the market is not detected, yeah.
In this game, is there exertion? Like, does it take effort to pull the cords? Or is it just up and down?
I don't think there's too much effort involved, but this, I haven't used this, so I don't know what it feels like. That would be, that's a Clement question. I'm
You
just
said
making-
it was a physical therapist, right? So maybe.
I don't know if the
emphasis
physical
was-
therapist was involved with
Oh.
it, but that was like the problem
Okay,
space they
got it.
chose.
Cool.
Sometimes design students choose problem spaces.
Yeah.
that
Okay.
I would.
Yes.
Any other questions about the portfolio?
Did you build this website yourself?
Yeah,
Okay, it's nice, I know.
we based it off a template that Sandra gave me, but it was using some thing that I didn't understand, so I just built it. It was like, it was meant for like data visualization for like things that have been passed around for a lot of things, but it didn't support this.
Mm,
That's what's really cool.
mhm.
You didn't really, maybe you talked about it, but I missed it. You didn't really talk about those builders and the kinds of.
Not in the presentation, no.
Interaction. But that's kind of good.
I think you should. talk
Maybe you want
about
to
it.
expand on it right now, just like to show the types of interactions. that are
Oh,
possible.
yeah, so this was something that we also cut for time, because there's a bunch of them, and we just wanted to get through the highlights. But so, it's a little small.
Well, basically, whole bunch of projects were done, and then the question is to reflect that all the different projects, are there something similar? Do they
Yeah.
belong to the category? So annotated portfolios is coming up as an afterthought to say, okay, let's annotate them, say, here are the different interaction modality. And so each one a project, and so now you have this annotated portfolio, you can select each one, say, oh, if I want to do rotation or sliding, and then how many project is doing that?
Yeah, so in the paper. The figure is like this, and we have each. We have each game or project labeled next to it. And so we categorize them by what is the interaction that the person is doing, so rotating or rolling. And then what marker property is it detecting? So for rotation, if it's just the marker in the center, that's just rotating the marker itself. For position, you can also do like radial coordinates based on two markers, which can sometimes be more reliable. And then you can also do just presence for it's rotated, a new marker is visible. And that's kind of what we did for each one of these things, how we broke them down.
Yeah, I'd be hoping that someone in the audience asks a question and forces you to say this.
Yeah.
please.
Yeah.
Because this is important.
Okay,
I kind of want even like, if you don't have the last slide, just the thank you slide, maybe just
Have
open
this.
up and
Yeah.
it'll invite more.
Oh, have a
of
QR code so they can scan and go to the annotated portfolio.
But
so
maybe
people
just like
stuff
put it
I
up
like- I
in
like
front
that.
of their,
Trigger for somebody to
yeah.
say, "Hey."
Trigger everybody say, oh, you mean I can select something and see the project? Cool.
and then you get to talk more.
Then a lot
Let's
of
go
it
ask
will
like
make
this.
sense when they heard and then they
Yeah.
actually see it and
yeah,
be like, oh, that's how you.
It also wasn't clear until you said it, that there's this sequence of the action and the sensing and, right,
Mhm.
your orange, blue, green, blue. Until you said that, I had no idea what those little tags meant.
all right, then I'll just add that
And I
slide,
like
'cause
it.
there are 3 slides that I was already thinking of cutting, so I'll just put this one in. I'm taking notes, and then we can go on to having fun.
Well, I like seeing all the little animation
Yeah.
for each
Yeah.
one of the.
You guys can go to the portfolio website now if you want, it's live.
Right, but you.
It does not work on mobile, I did not do mobile styles, don't judge me for it,
I don't know what.
it was extra.
Okay.
The word affordances comes to mind, but I'm not sure how to think a sentence with that word in it.
Yeah, I instinctively steer clear of that word, because that can be triggering for some people. As in, they will hear that word and not think about anything else for their
Yep.
presentation, but there will always be people like that. so.
But there's, I mean, you've got something in your hand, you can flip it, you can rotate it, you can
Yeah.
twist it, and those are all the things that you.
I mean, these are all the.
Well, I'd rather you say that instead of using word affordance.
I like to trigger people.
Yeah, and this I don't think is an exhaustive list, this is just what we saw.
Yeah.
In the projects, I'm
Yeah.
sure there's more possible things. As I've been sharing Beholder with other people, I've seen the scale of interactions that they're trying to increase, so Danny's been sharing it with some of his students in the alt arcade class. And they're like they took a workout tool and put some markers on it, and are trying to figure out how to track its position with that.
Wow.
The Arduino is bothering them.
Okay.
But I'll go on to the next thing, I need my dongle.
Okay, that's good.
So the thing we're working on now is still called Beholder. And we're gonna forget that the other thing is called Beholder. Because I like that name for this. So what we've got is, let me get my.
The problem is calling the different version of the software.
Beholder Plus, I like Beholder Plus Plus. Beholder.
Beholder.
Beholder, Beholder. Oh, I like that, Pro Max, that's a good one.
Okay.
Beholder Advanced, so, okay. So, what this is the idea, okay, so the last version you had to program. Programming's hard, I don't wanna do it. So what we're trying to do is make it so you have a little scripting environment that's super simple. That can output keyboard presses from this interface. So you've got the ability to open up a detection feed. And then connect that to like a marker node. Right now, we only support 1 detection feed, but the idea is in the future we'll support more. This is an old printed paper markers interface. And so I have this marker that can be detected. This one, zeros
There is
somewhere.
a camera over here, which is what you're seeing.
Yeah. So there's a little box over there with a camera. And that's what the interface is.
Paper with markers.
And it's got markers on the bottom that are cut in half. It wasn't designed for this setup, so we've got some false positives. But I'm looking for where, so marker 0 is all the way to the right on the top. Can you press that for me? Nope.
No, it's
Yeah,
this.
oh, yeah, that one, the one you
This
pressed
one?
first.
Yes, this one, right?
No. Yes, that one.
It's
So you
not
see those
detecting, right?
numbers are changing, it's not detecting it very well, because
This one is being.
they're a bit small for this
You
interface.
know this one's detecting much
If you
better.
want a bigger.
No, I can't. This image is too small, which is something we're gonna fix.
It's 3.
It's 3?
Okay.
All right, let's try it. So you can
Yeah, that's
change
right.
the marker ID by attaching a number to it. 3,
Right.
yeah, that's 3, okay. And then you can easily map that to like key presses. So I can now press the A key on my computer Once I hit this play button, it shall turn green when he presses that. And then if we go into a random notepad, he's pressing A.
Okay.
And so, the idea here for me,
And
all right,
writing your notes.
we're editing my dissertation. So that's the idea with the holder. So with the comp, I controlled it with an older version of this, and I'll do the same for my dissertation. You guys didn't hear. We're expanding these out based on what we think we need, but there's also like the ability to do angle change. So if you set a threshold, let's do 20 degrees.
Yeah.
27.
27.
That's 27. Okay.
Rotating ones.
Thank you. And then you set key for it to press. Let's do a new one.
And, okay,
And so now every time Krithik rotates it 30 degrees in one direction, which is backwards, it'll press F. So, so you can do the same thing in the other direction with a negative number. And it automatically stops running the keyboard emulation once I make any changes, because that caused problems when it was trying to edit at the same time I was.
yeah, conflict.
But so now we can do -20, and so this you could make an interface that equates to arrow keys, but is doing rotation. One. Nope, not that again.
Do something else. Okay. Now. Rotate, yeah.
And so that's, and we made a functioning version of hot swap with this that will have at Kai, but I don't have here because it's in Singapore.